My name is Troy Richardson. I'm here to demonstrate with this little toy track how momentum works, how gravity works, and how the radius of gyration changes. You'll notice that the mass of this steel ball is much greater than this plastic ball. And you have some marbles here that weigh about the same. They're about half or about 3 times less weight than this marble or this steely, and about 2/3 less than this one. I'm going to go ahead and release the 2 marbles down first. If I release them at the same time, they're going to travel down the hill at the same time, and with their weights being very close, the radius gyration, there shouldn't be much difference. Notice how that release is very good. They're going to travel back and forth. Granted, there's some factors of coefficient of friction, radius of gyration that play into this. We sell Zipline braking systems, and we're doing this demonstration to show you a little bit about why momentum is the critical factor on a Zipline. Because it's the heavier rider that comes in faster. Most Ziplines limit their riders to 80 pounds due to that, because they don't have enough momentum to get them up out of what we'd consider the belly of the cable. And so I'll go ahead and release this steel ball with the plastic ball, and watch how they both travel down about the same rate of speed. Very close to each other, but you notice how the steel ball takes over and surpasses back and forth because it has much more mass. There is a slight difference of coefficient of friction. The radius of gyration is very close, but the steel ball will continue to roll as the marble or plastic ball stops. Now we're going to run a marble and a steel ball. They're about the same size, so radius of gyration is going to be minimal, but the steel ball does weigh more. But notice the weight is not going to make it much faster going down this hill, but what it does is when it gets to the bottom, it has more momentum to carry it up the hill. In fact, the marble actually surpassed it. I released it a little bit faster, but you'll notice how the steel ball passes it back and forth. It's traveling at a much faster speed, and as the marble is stopping, the steel ball is going to continue. So we'll go ahead and release them again, changing sides of the track. See if I can release them about the same time, because gravity is a constant, 9.8 meters per second, and we want to just demonstrate that and really show you what momentum does. We always recommend, when zip lines have a maximum weight of 250 pounds, that they test with a 300 pounds, at least 50 pounds more, just because the momentum is going to be greater, the speed's going to be greater, and sometimes it's hard to tell the weight of a zipline rider. Muscle is heavier than fat, and a big bulky guy will weigh a lot more than someone that may look the same size but it's all fat. So I'm going to go ahead and release it. That last release was very good. They traveled down about the same speed, which is gravity, 9.8 meters per second. And that was a good release as well. Notice how the steel ball keeps passing, going up the hill farther, because the momentum is greater, the mass is greater, and so the marble is going to actually come to a stop, and the steel ball will still be running. So we're going to go ahead and release. We're going to run another marble with a heavier steel ball, and we're going to this heavier steel ball is probably 3 times the weight of this marble. It does have a little factor with radius of gyration. The radius is slightly bigger, so it'll roll faster. And I released it slightly different there, and so we're going to go ahead and stop that and try to get it simultaneously released, so that you can see that gravity is a constant. Notice how that was a pretty good release, but where the big factor is the momentum, as this steel ball keeps going back and forth, surpassing the marble each time, because its speed is much faster due to the weight of the ball and the momentum that is created. Go ahead and run a plastic ball with the marble, just once again, just to see if we can get those two rolled down very close to each other, but you notice that the heavier marble keeps passing the plastic ball. It's got much more momentum, about twice, and so it'll continue to roll. This is a good physics demonstration to show you that weight of riders is a big deal with zip lines. You want to make sure you have a good zipline braking system, because over half of the accidents in zip lines are related to braking, because people don't understand that heavy things and light things travel down the zip line about the same rate of speed, but it's coming out of the belly, or the lowest point of the cable is where the momentum takes over. Notice how I'll release these two. They travel down about the same rate of speed, but since the steel ball has much more momentum, it's going to continue to surpass the marble, traveling up the hill much further and back and forth, and it'll actually keep rolling as the marble stops. I want to thank you for this demonstration and taking time to watch it. Momentum is a big factor in zip lines, and you need to be careful with it, because people can get injured on your zip line if you're not using the proper emergency brakes. Any zip line that has a speed of over 6 miles an hour is required to have emergency brake, which is a standalone, not activated by a participant or a staff member, like a spring system. That's what you need if your zip line's faster. There's several ways to test, and I have testing videos that show you can use GPS, you can use GPS watches to get the right speed of your riders. Thanks for watching, and have a great day.